Okay, mic on. Hey, there's my voice. Here it is. How about yours? Can you talk?
Check. Right? We good?
So trying to see back there. Oh man, when I start talking, it's going to get really loud. Holy moly. So, who do I look at to see if we're ready to go? Looking in the back of the room. Are we rolling? We rolling? We ready to go? Are we ready to start the presentation? Yeah. We're up? Okay.
Okay.
Hello, everybody. Now that we have that out of the way, welcome to your next session of the day. Thanks, everybody, for showing up. I'm Jason Olson. I'm a program manager on the Creative Media Experiences team in OSG at Microsoft, and this is my partner in crime.
I'm Bala Sivakumar. I'm a program manager on the Creative Media Experiences team with Jason, and I handle the audio side of things.
So out of curiosity, how many people in the audience have actually built, hey, I recognize so many faces, it makes me smile. How many people have actually built like an audio or video app before? Ooh, a good number of you. How many of you are C# developers? How many of you people are C++ developers? How many people like writing C++ versus C#? Good. How many people of the C++ developers have written Media Foundation and Media Foundation Transform code? How many of those of you that have done that enjoyed the process? Okay, finally, all hands are down. Okay, that's what I kind of figured. Okay, well, we have some good stuff for you today then. I'm just going to go ahead and dive into this. Quick business thing, remember to fill in an evaluation form. All you guys have seen this. I'm just going to skip this till the end of the talk. So one of the things as a creative person myself, outside of work, I'm a musician and do a lot of creative work. One of the things that I love is no matter where I go, I always have some type of device within reach. So whenever that inspiration hits, I can go ahead and capture that on my device. I can just reach over and capture that latest song idea or the latest film idea and really just go with it before the muse leaves me. The problem is to really have a great experience doing this, you need to have great apps that you can interact with as a user. And what we're here to talk about is really how are we making it better to build those great apps for all of you. So we really want to talk about the story of building these great creative and video apps really easily on the Windows 10 platform. So diving into this today, there's a couple areas that we're going to talk about. We're going to talk about kind of the video editing experience and what we're doing around creative video. We're going to talk about the creative audio side of things and what we're doing there, as well as touching on some music-oriented APIs like MIDI and stuff like that to tell you how we've evolved in the last year. And then, of course, we just want to focus on lots of demos, lots of code to show you guys all of this stuff, hopefully all of this stuff, working on the bits that you have available to go grab and start using today. So first, let's talk about creative video experiences. When we actually take a look back and look at how media editing exists today, let's say on Windows 8.1, yes, we have a fully customizable video editing experience in Media Foundation. Very powerful. There's a lot of things you can do, but it requires a lot of lower-level code, requires a lot of domain expertise, and frankly, takes a lot of code to do even the most basic of scenarios. Like, let's say I want to do basic things like combining one video onto another video. I want to overlay one video on another video. I want to work with those videos by, let's say, adding a background audio track or something like that. Any of those scenarios that should ultimately be really easy and are kind of the basic scenarios in a creative video experience become incredibly difficult when you're having to do it with Media Foundation today. So one of the things that we did that we announced last year at Build is on Windows Phone 8.1, we introduced this new media composition API that makes it super, super simple with just a couple lines of code to do the basic things like trimming a video, stitching different videos together, adding background audio, and so on. Now to show that in action, let's say I want to do a simple thing where I just want to trim 22 seconds from a file. Well, once again, we're talking about just a couple lines of code here to do this kind of thing. Let's say I want to build a slideshow where I want to take my favorite 30 photos and have each of them displayed for 10 seconds and then encode that to a video and be able to send it out to my favorite social network or what have you. Once again, with media composition in Windows Phone 8.1, this became a lot more simple to do, where we were just talking about you just add the photos as media clips, add them to this composition, and you can bind that composition to a media element, use media transcode or anything to save that out. Very, very simple. But one of the things at the start of Windows 10, we started asking ourselves, okay, that's great and all, but what do we need to do next? What's kind of the next things that need to be done? And one of the first things we realized, any of you who have been in the video space for a while have started to realize video is starting to not be a stagnant thing anymore, or a static piece of content that you work with. It used to be that maybe I have a bunch of video files on my computer that I grab those, I manipulate them, I edit them, and then I produce some video file on the output. Well, what we're seeing now is video is becoming a lot more about interactivity. What are the ways that users are wanting to interact with the videos? And one of the cool things is those interactions are actually starting to be captured in the content itself. So some great work from partners like TechSmith with their Coach's Eye app, VanettaSoft with their Movie Maker app, and even our own HoloLens product. You see this idea that now I'm annotating on a video, I'm inking on top of it, I'm wanting to manipulate it in some way, and those actions that I'm taking with the video are the things I want to capture and actually save out. So then we started to look, okay, this is great. We introduced some cool features in Windows Phone 8.1 that a lot of people really enjoyed. How do we take this role of interactiveness and bring it to Windows 10? Well, the first kind of obvious step is we need to take this media composition API and bring it to the universal Windows platform. So now, media composition, you can use this regardless of what device you're running, as long as it's a universal Windows platform device. So you can run it on your Xbox, you can run it on Windows Phone, you can run it on Windows, write the code once, and that exact same code runs on all the different device families. But then there was still a gap we had to fill. That's great for the basic scenarios like trimming and stitching and adding audio. But the other ways that you want to interact with video, creating cool effects, maybe overlaying one video on top of another video. Maybe I want to overlay photos on top of photos, or any combination of the sorts. You know, those were, once again, immediate steps where you could use media composition for the basic things it was designed for, but then you ultimately fell off this cliff of complexity where now you had to dive down back into Media Foundation and be working in C++ again. So we added some cool things in Windows 10 that bridges that gap. We don't want you to have to fall off that cliff. We want to keep you in the things that keep you focused on adding user value to your experience, and that will keep your users coming back for more. So rather than talk and show you all this kind of stuff, I just want to code it. I would rather drop into Visual Studio, switch this over, and show you some of this in action. So what I'm going to do is I'm going to first leverage the basic stuff that we did around media composition, and we'll see this app in action in a minute. The first thing I need to do is create a media clip. I've already had the user pick from a storage file, and then I can just take that media clip and I can go ahead and add it to our composition. And now we have a media clip to work with. Well, we were talking about the power of overlays. Now to actually make this in overlays, the great thing about the overlay support now in media composition with Windows 10 is that overlays also build on top of media clips. So anything that could be sourced from a media clip before, an image, a file, a photo, a color, can also be used as overlays. So let's go ahead and add some overlays. What I'm going to do is up here, I'm going to go ahead and add an overlay layer, which we'll talk in a minute what an overlay layer is. Media, okay, composition, overlay layers, and I'm going to add that overlay layer. Now, of course, now we have this overlay layer. Think about an overlay layer as kind of like a container. It's something that we can throw a bunch of overlays into. So if you want to do 12 overlays and keep them in one rendering pass, or you want to animate them together or something, you can group them together in this concept of a layer. And we'll actually show one of the other cool things, custom compositors, that are made possible with this idea of overlay layers. But let's go ahead, before we do that, let's go ahead and add some overlays. So once again, I mentioned, so you create an overlay, and we're going to add that media overlay to our overlay layer that we added. And you can see the media overlay. We just passed it a clip. The rest is basically the position that we want to overlay it, and we can give it an opacity and that kind of thing. So actually, to show you how many overlays we can handle, let's do the same thing and add the ability of doing some other overlays as well. Go ahead and run this. Now this project, you'll notice it's all C#. When we get further along, you'll see that I'm going to be using Win2d to do a lot of cool stuff in the overlays and effects. And with the new Win2d support and all that kind of stuff, part of the reason it takes longer to compile is, of course, it's using Project N to compile this all natively. So let's go ahead and add a base video. I'm going to add an overlay. If I play that, you can see the top left, we have one video that we've overlaid on top of another video. Once again, no graphical hiccups or anything like that. The top left actually has opacity, so you can see the bottom layer through it. Really easy. Just, once again, a couple lines of code to get this. But you know, I'm not all impressed by that. What I want to do, let's add a couple more. I heard people really like photos of kids, so I'm going to add a couple overlays from my first son about 6 years ago. Let's play this. Now you can see we're overlaying 4 videos on top of a base video, and each one of them have opacity, and we're managing that. Once again, we're talking about just a couple lines of code rather than the literally thousands of lines it would have taken in Media Foundation. Once again, cool, nice and simple, really easy. I like this. But you know, that's not all that special. Let's start showing you some of the cool stuff that we can actually start doing. So I'm going to come over here, and when I create that layer, one of the things you'll notice is there's an overload for a media overlay layer where I can actually pass in a custom compositor definition. So I have a custom compositor that we're going to build here. Let me give it that. So we're going to use this example compositor that I've built. And in this example compositor, if I go here, an example compositor is just something that implements this new UWP interface iVideo compositor. And if we can go there, the methods that are most relevant that you can see is this composite frame method that will give you all the surfaces that you need to overlay, and then you give us the output frame on the context, which we'll see in a minute. And then set encoding properties, where we'll tell you how the video is encoded and give you the Direct3D device, so then you can use Direct3D, you can use Win2d, you can use anything like that to actually do your overlays with, which is actually what we're going to do. How many people, did any of you in the room go to Simon Tao's talk before this on Win2d? Okay, just a couple. So you guys are going to see some fun stuff here. What I'm going to do, this is all Win2d. So once again, we're all in C#. And I have this composite frame context, where if I go into the definition of that, we give you the background frame, which is the base that you're overlaying on top of. And we give you a bunch of surfaces to overlay, which you'll see all these are just iDirect3D surfaces. So anything that can work with those basic interfaces and interop with those basic interfaces, you can use to implement a custom compositor or as an effect, as we'll see now. And then you just give us the output frame. So what I've done in this setup is I've created the output surface from that output frame on the context, and then I've created a render target and a drawing session, which are from Win2d, to basically be able to draw to it. So of course, one thing that I want to do is I want to go ahead and, no, I don't want to search. I want to get all the surfaces that we want to overlay. And one thing that you'll notice, if then I look at this, remember we specified like the position and the opacity and all that kind of stuff. But at this point, we're just dealing with the interop types, this Direct3D surface. So it's just a Direct3D surface. We want to go get that original overlay as well, which you can do directly off the context object as well. So I'm going to say overlay, context, get overlay for surface, and I'm going to pass in that surface we're overlaying. And then I want to draw it. So rectangles are boring. So let's actually draw the videos as ellipses, just to see if we can. I'm pretty sure we can. At least the other times I've run this demo, it's worked. So let's draw the overlays. You can see I'm creating a canvas image brush, another Win2d construct, from the bitmap, which is essentially the overlay surface that we've given. And then I'm using fill ellipse with that brush to actually paint the image onto the overlay and the output frame. Now, something else that we have heard common feedback about is this is great and all, but then people, a basic scenario that they might want to do is text overlay. I want to actually overlay like a title slide or something like that on top of a video. Once again, before, even a basic scenario like that, if you were in Windows code, would require you to drop down to Media Foundation. But now, since I'm in Win2d, I can use the draw text as part of the canvas drawing session in Win2d to overlay some text. So let's go ahead and run that. Once again, it's going to take a bit to build because this is all compiling again with Project N. And as we come up now, I'm going to go ahead and overlay all the different, configure this again with all the different overlays. Add our base one, that's pretty cool. Add that overlay. Let's add the 3 kid ones. And I'm going to play this. You'll see we have text drawn, we have all the videos. All this is graphics accelerated. It's all in C#. So you can see, even though we're overlaying text and we're overlaying 4 videos on a base video, there's no glitches in performance, and it all just runs perfectly smoothly. Okay, now we're kind of stepping it up a bit. As Bala would say, now we're cooking with fire. So let's actually move this along. And later we're actually going to see one of our partners, what kind of cool stuff they've done with that custom compositor work. So let's talk about effects. Let's say I want to do some type of image filter that's applied to the video. Before, no lie, I went out to MSDN, I grabbed our official sample on here's how to do a grayscale effect in a Windows Store app. It's about 2,000 lines of Media Foundation transform code, a lot of plumbing and everything like that, because once again, Media Foundation, incredibly flexible, incredibly powerful, but kind of overkill for a lot of things. Using this new model, we're talking about 90 lines of code, which that boils down to basically 5, maybe 6 lines of Win2d code. So about a 96% reduction in code to do basic video effects with this new model. Now this new model, there's kind of 3 key things that we talk about that we like about this model. First of all, like I mentioned, it's universal Windows platform based. So you write your effect once, it'll run on Windows, it'll run on Windows Phone, it'll run on Xbox, all that kind of stuff. So once again, allows you to focus on the things that you care about, and they're going to be upsells for your users. One of the other things is, of course, using existing libraries and code. Since we interop everything as just a direct 3D surface and a direct 3D device, if you have existing shaders, like DirectX shaders, HLSL shaders, you can use Direct 3D to actually apply your own custom shaders to these video effects. If you want to use the Lumia Imaging SDK, we also have support for another construct called Software Bitmap, which is a common piece of technology that allows you to interop easily with the Lumia Imaging SDK or other SDKs out there that allow you to do CPU-based image processing, and as well as we just saw Win2d. And the other thing is it's usable across the entire media stack. So while we're showing it, while we will show this in the use of media composition, this is stuff that you can easily apply these effects to media element, to media capture, to media transcoder, any of those other media APIs. So once again, you create the effect once in a very powerful way, and you can use it anywhere you want across any device family, across any media API. So let's actually show the implementation of an effect. Rather than talk at you about what all this looks like, let's actually just show it to you in action. So one thing that I need to do on that base video, let's add an effect to it. So adding an effect, we have these video effect definitions. This is part of the API that was shipped in Windows Phone 8.1. So I'm going to create, not that, I'm going to create a new video effect definition. And I'm going to pass in this new saturation video effect that we're doing. You might ask, why this extra rigmarole of a video effect definition? Why can't I just pass in an instance of an effect? Well, one of the major uses of media composition is it's basically just a graph that represents the operations you want to do. It's in the typical nonlinear editing, it's non-destructive. So it's just defining the intention of the operations, and what you can do is you wire up the entire media composition, and you can actually persist that to a file and save it as a project, and then load it later. So this way we can load, by having that ACID or the runtime class name, from WinRT, we can actually load those only as needed, and it allows us to kind of deflate and reinflate the media composition graph. So let's implement this saturation video effect. Once again, you'll see it's just implementing an interface, iBasic Video Effect, which is a new interface in Windows 10. And it boils down to, once again, the set encoding properties that here we're creating a new Win2d canvas device with the direct 3D device from the media pipeline. And it's basically a process frame method. If we look at the context, you'll see there's an input frame and an output frame. So we give you the input frame, you give us the result in the output frame, and then we will use that in the rest of the pipeline. So to do this, let's do the same thing where I'm going to set up Win2d, have the basic things of using the canvas drawing session to render to the output bitmap, and then grab the input bitmap. And once again, this is a Win2d saturation effect where I'm going to pass 0, 0, so it's grayscale. You can see just a couple lines of code to do a grayscale effect as opposed to that 2,000 lines of MFT code. But I kind of want to make it a little more cooler. So one of the things I have is in the app, you might have seen a slide bar. While the video is running, I want to actually control that slide bar and change the parameters to the effect while the video is running so that a user can perhaps preview how they want the effect to look and then snap on that value. So everything in the property set configuration or in the configuration of the effect is based on property sets. I've created this property set that if we look here, I'm passing in a saturation value based on that slider. And all I need to do is when I create the effect, add this effect, I'm also going to give it that configuration. And then in my effect, every time I process a frame, I'm going to read from it. Let me create this parameter. So in set properties, a different method, we give you the property set that was given by the initial when we configured the effect. And then instead of 0, 0, let's read that property. So every frame, I'm going to read that property. We'll go ahead and build that and run this. And after it builds, this will allow us to press play on the video and then actually tweak the slider value while the video is running. I'm going to add all the videos just to show you what we're talking about performance-wise. You can see already the preview has it already fully saturated. I'm going to create all our overlays again. And hit play. You can see we have the overlays going, and if I change the slider while the video is playing, you can see I have full control over this. No graphic hiccups, anything. This is still GPU accelerated, doing everything I need to do. Okay, so this is a quick one. Let's actually, before I bring my partner up on stage, I want to show you some cool stuff that David and Danielle did. They're in the audience somewhere, I'm pretty sure. Hey, there they are. They're in the front row. So they're the creators of Movie Maker 8.1 on Windows Phone, one of the top paid apps in the store. And we worked with them with this new API to say, hey guys, we want you to go create some cool stuff with this. So I want to show off what they actually did for us in a very short amount of time, actually, to show you the power of this. And keep fingers crossed that a reboot of the machine didn't break this demo. So this is a preview specifically for the build conference of Movie Maker 10 that they worked on. And you can see I can play it, and then I'm scrolling through, and I can append clips and all that kind of stuff. The cool thing I want to show you is they added transition support. So via this overlays, here's a simple fade that you'll see. You can fade to the next one. Let's do a slide. I'm actually going to do a different easing animation. Let's bounce it out from the top, and let's zoom on it when we're started. Play that. And we'll see boom, 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 boom. Let's get fun though. This is where we cross our fingers, hope that this works. Because I want to show you some of the cooler ones. Let's do something called slices. Okay, that's pretty cool. Let's alternate them. Remember, this is all C# code. I think David said this is about 10 to 11 lines of C# code. Okay, that was cool. This is the more cool button. I like that. All the way up to 500. Let's go up to 500 slices and see how this performs. Look at that. Let's look at that again. Now, when I play it again, actually look at the right side of the video, and you can see the original video as we're doing the effect is still animating. It's still playing. So we're processing the frame every time. Yeah, and that, once again, C#, 10, 11 lines of code. I think they said to build this entire app took them 30 hours, something like that, 30 hours to bake. And a lot of the time was learning Win2d because it's a bit of a different kind of mindset to get into if you've been using the Lumia imaging SDK or something like that. What do you guys think? Like it? Okay. Very, very, very cool stuff. So I'm going to pass it over to Bala, who's going to come up here and talk to you about some of the next stuff that we're working on in the creative space.
All right, let's see if we can get this party rolling. Jason started the party with video stuff. Let's talk about audio stuff. Creative audio experiences has been a focus for us in Windows 10 in general. We wanted to make it easier than ever for you guys to write creative, interactive, and music applications on Windows 10. And what does this mean for you guys? What this means is that you guys can concentrate on writing code that makes your app unique and your app special instead of having to spend time writing code that is like the underlying pipeline or the foundation part. And the first part that we did is invest in MIDI. Some of you may remember that last year at Build, Jason introduced the preview version of our WinRT MIDI APIs. So why did we invest in MIDI in the first place? We invested in MIDI because, as a lot of you guys who write music apps or are musicians themselves know, MIDI is the glue that holds music creation together. It is used to connect and control all kinds of devices. It's used to connect computers, controllers, digital instruments, synthesizers. Well, even MIDI is also used to control some lighting equipment. It's a pretty fascinating protocol. So we released this as a preview API, mostly in a NuGet form for Visual Studio. We released this to get feedback from you guys for the kind of features, capabilities that you want to see in the space. And some of the biggest feedback has been that you want to see this not as a NuGet package for Windows or Visual Studio, but you want to see this baked into the platform. So our first step towards addressing this feedback has been to actually go ahead and bake this into the platform. And it is now available on all Windows 10 universal app platforms. But what does this really mean? Instead of talking about it, I think it's more exciting to show you guys a demo. So let me go ahead and show you guys this demo of a little app that we have written. Let's see if the demo cards are with us. OK. How many of you know what this is? OK, a few of you know. For those of you that don't know, this is a Novation Launchpad. It's a MIDI controller. It's got a bunch of buttons that you push to send MIDI commands to the device at the other end of this connection. Here I have a computer. It's used to create all kinds of cool scenarios. You guys should just go online and search for videos. People do some amazing stuff with this. And today, we're going to use this in a somewhat non-traditional sense. We're not going to use this to send commands to the computer. We're going to do it the other way. We're going to send commands to this device from the PC, and the commands that we're going to send is to turn on some LEDs, which are underneath these buttons. We're going to make it look like a leaderboard of sorts. So let's see if this works. OK, we have this here. So I hit connect to Launchpad, and then I hit do cool stuff. Can you guys see this? Can you guys read the text, what it says? OK, it says, hello, Windows 10. That's what it says. This is all cool, but what does this mean for a universal Windows platform API? You can do this with any Windows API, right? Where it is really cool is the power. I have here a Raspberry Pi running Windows 10 and another Novation Launchpad connected to the Raspberry Pi. I'm going to now deploy this exact same code to the Raspberry Pi over here without changing a single line of code and show you guys how that's going to work. No. OK. So let's see. OK. So this is actually running on the Raspberry Pi. Exact same app, 0 code changes. All I did was change the target and deploy it. So I click Connect to Launchpad, do cool stuff. Same thing over again. How cool is that? Exact same code running on a PC, a Raspberry Pi 10. Sorry, a Raspberry Pi 2. Can you guys imagine? I mean, it's such a little tiny device. So this gives us this shows the power of what the universal Windows platform can really do. So let's go back over here. But that's not all. Sure, we put it and baked it into the platform, and we made it part of the universal Windows app platform. But we've done more than that. You guys give us a lot of good feedback, and we've heard this feedback, and we've tried to incorporate it. The first one is give it shared device access. This means that more than one app can actually communicate to a connected MIDI device simultaneously. What this means for developers is that you can now write your apps without having to worry about what other app is accessing this MIDI device. You can concentrate on your creative scenarios instead of having to worry about devices. Another piece of feedback we received was that you wanted to use the inbuilt synth in the platform as a MIDI output device. So we've made this accessible now through the MIDI APIs. The Inbox Microsoft Wavetable GS Synth is now listed as just another MIDI output device. It will be enumerated in the MIDI APIs. You guys can use it. You can play sounds via it, all of that good stuff. The only thing to note is that the sounds are pretty large in size, so especially when it comes to things like the Raspberry Pi 2. So we've made this available as a framework package from the Windows Store. So you need to declare this as a dependency in your Apex manifest in your Visual Studio project, and it will be pulled from the store dynamically upon app launch. The other part that we also did for the synthesizer is that we increased the performance and the latency characteristics of the synthesizer. And that's not all. We're continuing to improve the performance of the synthesizer in future releases. And the other aspect that we improved for MIDI is device naming. Traditionally, Windows has had some, we've gotten feedback that the names that the MIDI API show are not intuitive. So right now what we do is we try to query the firmware of the connected MIDI device to see if there is a logical name that exists over there, and we plumb that through. So when you're querying the devices through your API, you find names that you would identify it for the devices as well as the ports. So all of this is great, but what else did we do in the field of interactive audio? What we have done is we've gotten some feedback that we have a bunch of audio APIs, but they're not always the easiest to use because some audio APIs are very high level, some audio APIs are very specialized. And let's walk through that with a simple scenario. How many of you here have done karaoke at some point? Yeah? All right. For those of you who have never done it, today might be your lucky day. We'll see if we can get you on stage singing karaoke with me at the end of the session. What was that? All right. So let's draw the block diagram of what we need for karaoke and walk through it before we actually go into discussion of these APIs. For those of you that don't have done karaoke, you know the scenario. It's pretty simple. You have a microphone, you have a speaker, you have a connection, right? But what's important also here is that you need a connection that is low latency. It is important to have low latency because nobody wants to hear an echo of themselves when they're singing into the microphone. And what you also need to have is a backing track. You need to have something like song.mp3 that you play in the background when you're singing on top of it. That forms the basis of your song. We're going to make this scenario slightly more interesting with the potential for blackmail by recording this to a file. So whoever is singing, we're going to record this to a file. And this is pretty simple, right? But these lines you see are getting messy. So let's clean that up, but keep the scenario simple. Let's add a submixer or a mixing. Let's mix these two signals. It's still simple. The mixer has 2 inputs, 2 outputs, pretty straightforward, right? I want to make the scenario even more interesting. I want to apply some kind of an effect on my mixed signal. Let's say, in this case, I want to apply a reverb signal. I want to make myself sound like I'm singing in a cave, or maybe singing in a studio or an auditorium or something like that. And I'm a terrible singer, I will admit that. But I don't want to sound terrible, especially when the file is being recorded. So maybe I want to have some kind of an auto-tune or something like this for, say, the microphone that makes me sound not so terrible. And to make this scenario even more interesting, let's add a visual aspect to it that it analyzes this data and maybe does some spectrum analysis and displays some waveform, things like that. And let's now tabulate all of the things that we need in order to accomplish this scenario. I've listed it at the bottom over there. Pretty clear, right? I mean, there's nothing there that we didn't talk about. And we all want things to be easy to code. So let's discuss this in terms of what we have today. How would you do this? So let me paint a picture. The API landscape today is that you have some high-level choices. You have, say, the media element, which can do some of these things, not a whole lot. But it is high level, it's easy to use, right? I mean, it's a Win2d API, it's available in all of the Win2d projected languages, C#, JavaScript, etc. And then you have media capture, which again cannot do other things, but it is still easy to use. And the problem is there's no easy way to string these two APIs together in order to accomplish the scenario. So what other choices do we have? Jason alluded to falling off the complexity cliff. That's what you have to do in order to use C++ API. They're hard to use. Nobody wants to go to C++ unless you have to. Sure, it gives you a lot of power, but with that power also comes a lot of complexity. You have Xaudio, you have Wasapi, which are audio APIs, and C++ Rand, native stuff. But the problem with that is even things like playing back a simple MP3 file is not easy. Why? Because Xaudio and Wasapi don't understand the concept of MP3, which means to write a simple karaoke app, you have to now roll your own MP3 parser. I didn't sign up for that. I don't want to write my own MP3 parser just because I want to write a simple karaoke app. Same thing with saving to a file. If I want to write to like recording that MP3 or something, I don't want to have to write my own MP3 parser in order to figure out where to put what bytes. In order to solve this, we've introduced a brand new API in Windows 10 called AudioGraph. Like the name suggests, AudioGraph is a graph-based API. What does a graph-based API mean? It means you have the concept of nodes. The nodes accomplish different things. You can make them do different things, and you just string them along, and you realize whatever scenario you want. And as you can see, it suffices. It fulfills all of our scenario. And this is an API that has been designed with interactive audio in mind. You don't have to twist other APIs that were not designed for interactive audio to realize your scenario. Plus, you get to work in a high-level language like C#. You can do all of your coding over there. And the best part, it's a universal Windows platform API. So it runs everywhere, including the Raspberry Pi 2. And what does this mean in AudioGraph? So let's translate the objects that we saw, the karaoke, into AudioGraph objects. The AudioGraph uses a very similar concept. Like it calls these objects nodes, that it strings them along together. And the node names are pretty self-explanatory. You have your device input node, which is what? A mic. You have your device output node, which is what? A speaker. File input, file output, similar for you have your submix node. And like Jason mentioned, he introduced the iBasic video effect. Similarly, you have the iBasic audio effect that can be used all throughout the universal Windows platform APIs that you can use to process data. You can write in C# code without having to worry about writing heavy-duty C++ code just to have a simple effect. In his case, he was doing grayscale. In our case, we're doing a spectral analysis. So let's move to Visual Studio, where we're going to try and create this API or create this karaoke app with the stuff that we've shown. Okay. Okay. So what do you guys think that the different components that need to be there? We looked at a diagram. Let's build each of those diagrams or each of those nodes that we saw in the previous diagram in code. The first, we need to create an AudioGraph instance in order to bind all of this together. Before we create an AudioGraph instance, what do you normally need to do? You need to normally configure it with something. In this case, you configure it with what is called a settings object. So you first create the settings object, and then you pass the settings object into the creation of audio graph. So this creates the audio graph with the setting. For simplicity's sake, in our current demo, we're just going to, the only settings we're going to specify is the audio render category. And David, who is speaking in the coming days, is going to delve deep into what these audio categories mean. But for now, we're playing like media-related stuff, so we're going to pick media. This is the only non-optional part of the settings object. We're going to create the settings object, and we have an asynchronous method, create async, that is based on audio graph. It returns a result object. The result object has success or failure or what kind of failure, and if it succeeded, it has a pointer to the graph object that you then save. Easy enough, right? 3 lines of code. That's all you needed to create an audio graph. And now we need to do what? String it together so that we can hear sound from the speakers. That's it. 2 lines of code is all you need to be able to make a connection to the speaker. You have a line that says create device output node. Similarly, it returns a result, just like you saw previously. Boom, that's it. The next part is going to be creating a device input node for the microphone. That's it. You need to provide a media capture category over here. Please ignore the PC up to date. We're running preview bits of Windows 10, as you can tell. You create a media device input node. It's again an asynchronous method, so all of these calls are non-blocking. Then you return a result object in which you have a device input, and that's it. Pretty simple, right? And then what else do we need to do? We need to play a device. You need a file input node to play your recording.mp3. In this case, we're going to make things a little funky and play Twinkle, Twinkle, Little Star. Who here knows the song Twinkle, Twinkle, Little Star? Seriously, no one? OK, we're going to make somebody. Yes. We're going to see if we can get somebody that knows the song. So the real audio graph part is the last 2 lines. The first 2 lines, you open the storage file. They're standard APIs that you guys have used before, standard C# APIs. You open the storage file. In this case, I have a Twinkle, Twinkle, Little Star.mp3 inside my project. I open it. And I need to save my file into a recording like we talked about. So we're going to create a file output node. That's it. The first line creates the storage file. And then the second part and the third part actually is the audio graph code. Pretty simple, right? Is everybody with me so far? Anybody, did I lose? OK, easy enough. So you notice here I've created recording.wave. But that's not what we talked about. We talked about creating recording.mp3. The default option for audio graph saves to recording.wave. So we're going to do mp3 over here. But changing the file name isn't enough. So we're going to create a we're going to do this. These are APIs that already exist. And that's it. That's all you need to do to create an MP3 file. You wanted to create a WAV file, or you wanted to create a WMA file, or if you want to change the encoding properties, you just go ahead and customize your profile. That's all you need to do. And then we're mostly done, right? What else is left? The submix node. So we need to create the submix node, which is literally 1 line. That's it. Create submix node. Boom. But then this doesn't create your input, incoming and outgoing connections. So we're going to just create an input outgoing connections. We're going to wire them up. So you have 4 connections. It has 2 inputs and 2 outputs. The numbers that you see over there is the gain. So in this case, the microphone, I want to push up the gain so I can actually hear my own voice above the backing track, which is why the file input has, I've suppressed the gain, I've given it 0.5, whereas the mic, I've really amped it up really high and put it 5.0. And then I'm going to create a custom effect that Jason talked about using iBasic audio effects that in this case, I'm not going to do a full spectrum analyzer. Instead, all I'm doing is looking at the volume of the signal and returning the decibel value that I represent visually. We're not going to go into the implementation of the code over here, but we will discuss that in the SDK samples. OK, that's it. And let's see if this compiles. And while it's compiling, do I have a volunteer for somebody to come and sing this with me? Anyone? All right, come on up. All right. Everybody give him a hand. All right. So we're going to use this microphone to sing into it. So let's wait until compiles. All right. OK, I select a song. All right.
Up above the
world so high,
like a diamond in
the sky.
Twinkle, twinkle.
OK, everybody give him a hand. I think we've done enough. All right. I told you we're going to have a party over here. So let's see where it actually recorded. It recorded in the music folder. You have your recording.mp3 over here. Let's double click this and make sure that it actually plays. You guys see? All right, all right. Yeah, that was fun, wasn't it? This is all great. So what we haven't covered is, let's see how we're doing on time. We're running a little short, so we're going to skip the custom effects that we're going to have, the reverb and echo. Audiograph provides, let me just run you guys through a quick, simple echo effect. Let me show you the code. So all I do is create an echo definition, and then I have parameters. And I just add it to my submix node. By default, it's enabled, and I don't want to enable unless I click on a button to actually say enable this effect. So I go ahead and disable it, and then I have app UI where I click and enable it, all of that. And this is all great. So let's move to this. So the karaoke app was fun, but there is one part that we haven't talked about yet, latency. We said latency was important for a karaoke app, but we really haven't discussed how or why we address latency. First, let me go a little bit deeper into the topic of latency, because this requires some level of detail. And I want to make sure that you guys realize all of the work Microsoft has done in this area for low latency. First, we heard a lot of feedback that latency is very important for interactive audio scenarios and just any kind of audio scenario in general. For the pro audio, creative professionals, they've given us a lot of feedback. We've taken this seriously, and we have done a lot of work in Windows 10 to reduce latency. Typical numbers, for example, like a device like the Surface Pro 3, in Windows 8.1, it used to be 50 milliseconds round trip. We'll talk a little bit in a couple of minutes about what this 15 milliseconds means. And when you upgrade it to Windows 10, you will get a round trip latency of about 10 milliseconds. This is, you should get similar numbers on your HP Spectre that you received today as well. This will obviously depend on the device and the drivers. We'll get into a little bit of details in a couple of minutes about why. So let's spend some time talking about what this 50 milliseconds is. First, there are two large categories of latency that most people talk about. The first one is touch to sound. Touch to sound is the time you hear the audio from the moment you touch your touch screen. The second part is round trip latency. Round trip latency is when you have a microphone, you sing into it, the audio flows through the capture stack into the audio engine, and then it flows back through the render path out of the speakers, and it's the time you talk into the microphone to the time you hear yourself. And this is the part that we're going to be concentrating on in this session, because that's more related to audio. We're not going to cover the touch stack. So since I talked about the audio stuff, Let me paint you a picture of what the audio subsystem looks like. This is how audio looks like on Windows, where you have the application on top, you have the hardware on the bottom, you have the audio engine that sits in between, and then it docked to each other with buffers. The buffers are standard is a 10 millisecond buffer that you use to communicate between each other. The majority of the work that we've done in Windows 10, or a huge amount of work that we put into the audio engine, has been to re-architect and redesign the audio engine, that on the exact same hardware, you will get a minimum of 15 milliseconds savings in the round trip scenario. But what we have also done is enable support for smaller buffers. Smaller buffers means that each layer has to wait less for the other layer to handle data. And this obviously requires hardware support and therefore device driver support. So we've enabled new methods for the device to announce these capabilities to the audio engine, and then the application can then query this capability into the audio engine to figure out what kind of support happens on that particular device. All of this is great, but we still haven't talked about how to use latency in audiograph. I mean, all of this is moot if it takes like a billion lines of code to use low latency in audiograph, right? So let me just jump back to Visual Studio for a quick second to show you exactly how many lines of code it is to use low latency in audiograph. You remember the settings object we created to create the audiograph. All we need to do here is say settings dot quantum size selection mode, and we have to say quantum size selection mode dot lowest latency. That's it. One line of code. That is all it takes to go into the lowest latency mode on that particular hardware device. So if I now recompile this hardware, this karaoke app that I have on this particular hardware, you will hear an even lower latency, although that's mostly more obvious for the person singing it, because for the person hearing it, you don't really know when the words came out of the person's mouth. So we're going to skip the particular demo of that. I'm going to move back into PowerPoint. Okay, so that's all of the work that we did in Windows 10 for audio. And if nothing else, we want you to remember these top points when you guys leave the room, because we covered a lot. The first, we want you to remember what Jason talked about for media composition. Media composition was introduced in Windows Phone 8.1. We baked this into the universal Windows platform. We increased performance, as well as we have additional capabilities like effects and overlays. And the other stuff we talked about today is MIDI. We looked at a very cool demo of how MIDI runs in the universal Windows platform using the Raspberry Pi 2 as an example. And we also introduced a brand new API for interactive audio applications called Audiograph. And we introduced low latency audio and all of the work that we did in there. I want to say that low latency is a complicated topic, and it's a very deep topic, so we didn't really do justice over here to cover all of the details. We will be releasing a white paper with a lot of details on all the work that we did in low latency and how you can use it in Audiograph and Wasapi and all of the different goodnesses, how you can query the driver to figure out all of the stuff that it did. But that's not all. There's more to come. In build, you will see that the creative media experiences angle is receiving a lot of coverage. There's more news to come in the keynote tomorrow, which I think you guys will really like. And I want to stress that this is only the first step of many. We're continuing to make improvements to make Windows a robust platform for creative media experiences. We're doing a lot of work to drive the latency down even further, so we're listening to feedback. And we're also going to be there at A3E and Summer NAMM later this year, talking about all of the work that we did in audio. So if any of you guys are going to be there, please look us up. We're going to have sessions there to dive deep into this as well. So call to action. What do we want you guys to do? First, we want you to go to the Dev Center. We want you guys to download the latest Windows 10, the preview release. And then we want you guys to download the SDK samples that show far more examples and code samples than what we talked about in the session today, because we only have so much time. And then we also don't want you to download the Visual Studio and go party on these bits, go play with it, figure out what works, what doesn't work, et cetera, all of that. And Jason here, I want to give a plug out to his GitHub project where we're going to be posting all of the demo code that we showed today for you guys to play with. It'll be a couple of time before we actually get around to posting the code samples on GitHub. But Jason has old samples from last year's build with Wasapi that shows you the power and the subsystem, the audio subsystem, what it can do. And he also has a blog that will talk about our investments in the creative media experiences space that I highly recommend you guys follow. He's going to be doing coverage of both audio and video topics over there.
So that GitHub project right now is just a placeholder. So we expect to get stuff up there starting rolling in the next couple of days as the public bits become available, as the public Win2d bits become available, all that kind of stuff. Then we'll start really publishing to that Media Contrib GitHub repository.
Yes. And I want to stress that all of this is possible because you gave us feedback. You told us what you value. You told us what you want to see in the platform. So please keep that feedback coming. If something doesn't particularly suit your use case or scenario, tell us because we want to know. We want to build platforms that really work for you guys and APIs that work for you guys. So keep us posted. Tell us what works. Tell us what doesn't work, how we can improve, what you would like to see, all of that.
Great. Okay. Thanks, everybody.
Yep. We have our...
So for questions, we're running tight on time. You can come up and meet us here. We're also going to be in the Windows Insider Lounge
for the next hour or so.
Yeah, for the next hour and a half.
Yep.
Do you tweet? Do you have a Twitter account?
I do not.
Okay, so you can also feel free to contact me on Twitter. It's just at JOlson88, same as my GitHub name and all that kind of stuff. We would love to hear from you guys, so absolutely contact us anytime. Thanks, everybody.
Thank you.